All right, 4.2 is all about isosceles triangles. I know a lot of you already know some things about isosceles triangles, and maybe nothing today will be new to you, but we do have to go through it because we do have a few new conjectures. So on your notes, I would draw this picture with the parts of an isosceles triangle. Okay, the vertex angle is that angle that is between the two congruent sides. So looking at this picture, you'll see the congruent markings here and here to show which two sides are congruent. So that vertex angle is the one that is between those two congruent sides. We don't really talk about the legs or the congruent signs being the legs, so if you want to cross that part off or not write it, that's fine. It's not something we're going to expect you to know. It's not anything we really use this year in geometry. Next are the base angles. So the base angles of an isosceles triangle are the two that are towards the bottom or opposite the vertex angle. Okay, so if we have the vertex angle, we have the two base angles that are the other two in a triangle. We will be talking about some unique things about base angles here in just a second, so keep that in mind. Last but not least, the base. Okay, I think some of us consider the base of the triangle being towards the bottom, but we know that's not always the case because I could draw my isosceles triangle like this, and technically the base would be up here. Okay, the base is opposite side the vertex angle in an isosceles triangle. If I'm ever going too fast, please make sure you are pausing the video. Alright, so get out your conjecture sheet if you haven't got it out yet. The isosceles triangle conjecture: if a triangle is isosceles, then the base angles are, what do you think? Congruent. Okay, so if I draw a picture here, if we know the isosceles triangle is isosceles, if a triangle is isosceles, then the two base angles are congruent to each other. All right, then the converse of the isosceles triangle conjecture. So kind of like the opposite of the isosceles triangle conjecture. Okay, so just the kind of the conjecture we just talked about, but kind of flipped around. So let's say we have a triangle and we have two congruent angles, any two angles. Okay, then we can say the triangle is isosceles. Okay, so now that we know that two angles are congruent, then we can say it's an isosceles triangle. Okay, because sometimes you might just be given two angles are congruent, you might not be given the sides, or vice versa, like our last conjecture. Okay, so it's important to know that it works both ways. Yes, it's kind of repetitive, okay, but it's important that you understand that it can go both ways. Whenever you have one, you have the other. All right, we're going to go through a few example problems. First things first, okay, notice that we have two congruent sides. So that means, using our first conjecture, that our two base angles are congruent. So that means angle I is also 58 degrees. Thinking back to the conjecture from yesterday, the triangle sum conjecture, all triangles add up to 180 degrees. So if I subtract 58 two times from 180, I get 64 degrees for my third angle. As I'm going through these, if you want to pause the video and try to come up with the answer on your own first, that would be a great idea, and then you can listen to me to see if you solved it the same way. Alright, so here I have two congruent sides, and I know the base angles would be congruent. Then I see the right angle symbol on angle N, so I know angle N would be 90 degrees. So I'm also going to use my triangle sum conjecture, 180 minus 90, which I'm left with 90. Since I know angle G and angle A are congruent, I can divide that extra 90 by 2, so I'll get 45 degrees. Number 3 here, okay, so pause the video if you want to try and solve for x on your own. Okay, I see a linear pair with 110 and this vertex angle here. So linear pair means they add up to 180. So I know I'm left with 70 degrees here for my vertex angle. Next, we know our base angles are congruent, so I'm going to use my triangle sum conjecture, kind of like what we did in the last one. Okay, and then divide by 2. So I'm left with 55 degrees for my base angles. Then again, I have a linear pair here with x in this 55 degrees. So I'm going to take 180 minus 55, and I'm left with 125 degrees. All right, example number 4 is a little trickier. Now notice that we don't have any congruent signs to show that this is an isosceles triangle yet. So we need to find this third side or third angle. So I'm going to use the triangle sum conjecture to help me find that third angle. And actually it ends up being 39 degrees. So now we can assume that angle A or side A is going to be 13 as well. And then we also have this as 39 degrees. And they want us to find the perimeter of the triangle. So since A we found is 13, I can put 13 in for A. So 13 plus 7 plus 13 plus 13 for my other sides. So then I am left with, this gives me 20, this gives me 26, so 46 for the perimeter. Example number 5 is a little more challenging here. The first thing we have to determine is what that third side is, and they gave us the perimeter. So they gave us it's 536. So I'm going to subtract 210 and 163 from it. So when I do that into my calculator, I get 163 for that third side, LM, and we're dealing with meters. Then we need to figure out how to find angle M. Since these two sides are congruent, okay, we can use our isosceles triangle conjecture, and M would be the same as O. Now to find the measure of x, okay, we can use our triangle sum conjecture from 4.1. So I can add up x plus 30 for angle L, plus x from angle O, plus x from angle M, and all three of those angles should add up and equal 180 degrees. Okay, so I'm going to combine my three x's, and then I'm going to solve for x. Subtract 30, and then divide by 3. Okay, so my x would equal 50. Now, I said x equals 50. I didn't say the angle necessarily equals 50. So, but we're trying to find angle M. So, since there's just an x there, it is going to be 50 degrees. Okay, if we were trying to find angle L, we'd have to do 50 plus 30. Last example here. Again, they gave us some congruent markings, so I'm just going to say this is y plus 31 since these two are congruent to each other. They gave us the perimeter, Okay, so let's do what we did before, add up all the sides and set it equal to the perimeter this time, because we're talking the sides, not the angles. And we are going to solve for y. So I have 3y plus 62 when I simplify it. Then I'm going to subtract 62, and I get 282, and then divide by 3, so I get my y to be 94. Okay, so y is 94. We got to remember that. All right, so let's find QR first because we kind of worked on the sides first. And y is 34, so QR would be this side right here. So I'm going to plug 64 in for y, and when I do 64 plus 31, I get a side length of 95 centimeters. Then if we wanted to find angle Q, we know our base angles are both 68, so I'm going to do triangle sum conjecture and subtract the 68 from 180 twice, and I'm left with 44 degrees. Okay, please ask questions if you are still confused by these examples.